Hi, this is Bill Becker at Honolulu Community College, and this is the CENT 315 class, and this is topic 2. It's the second part of it, SNMP traps. Let's see if we can bring it in a little bit closer here. So you've seen, we've talked about SNMP, we've looked at the NMS where we were sending polling, and remember that they had polling? And polling is initiated by the NMS manager program, and the request is sent to the agent. Okay, that's what we did last time, using net SNMP command line. So the trap is initiated this time. What we're going to do in this lab is it's going to be the other way around. The trap is initiated by the agent and sends info to the NMS manager program, indicating that something has happened. So this is going to be the other way around. The agent on the switch, an event happens, the agent detects it, and on its own, it sends that message straight to the NMS. So it's called a trap. So NMS traps, it lets the agent tell the manager something has happened. The network interface could go down or up. Maybe somebody logs into a switch, there's an error. Maybe there's a fan failed. You can set that agent on the switch to report on any situation or any event that happens, as long as there's the MIBs and the OIDs available to do that. And so the trap on the agent will actually send it over to the NMS. So this time the NMS is listening on 162. Last time we used port 161 for polling, but this time for traps it's port 162 UDP, and the event occurs on the switch. The agent detects the event, it's programmed, it has the trap client set up, and it sends a trap. Now it sends it to a specific NMS. It's got to have the IP number on there. So the NMS processes the trap. So that's how we're going to look at that in lab 3. That's how that's going to work. Now here's a picture. Let me see if I can cut directly onto the screen here. So the trap is sent from the agent. So here's what happens. You notice we have the NMS listening on port 162. We've got the agent programmed to detect the event. The event occurs. The agent detects it. It sends the trap, and that's that little bit of information, a UDP packet, to the NMS, which is listening on port 162. Okay, and then the NMS processes the info and does whatever it's programmed to do. With net SNMP, it isn't really programmed to do anything specific. We have to program it. So we'll write a script in lab 3 to essentially process that information, receive the trap, and then process the information. And you note there is no acknowledgement in this case. There's no acknowledgement. It's just a one-way deal here. So what you probably notice here is that the trap message is sent from one application to another, typically from the device agent to the network management station. But the problem is that trap is unacknowledged. There is no acknowledgement. The agent has no way of knowing if the trap got there or not. If it's lost, it's lost. So they improved on that, and they have another very closely related, it's just like a trap, it's just an acknowledged trap. It's actually a trap that's acknowledged. They gave it a completely different name. They called it an inform. Now why they call it an inform, I don't know. But you see it here, it's simply an acknowledged trap. But they gave it a completely different name. I probably would have named it something else. So here's an example of that, and let me pull that up full screen again. We've got this time the agent is programmed to detect events and send an inform. An inform, that's that trap that's going to be acknowledged. So the NMS, once again, the NMS is the server in this case. It's the server listening on port 162. Remember, a server is the listener, so it's acting as the server. The agent is acting as the client. So there the event occurs. The agent sends the inform with the information to the NMS. The NMS not only processes, it returns an acknowledgement. Now, this time the ACK is sent. If for some reason the inform got lost, well, there's no acknowledgement. Well, then the agent will resend the inform. So it's more likely that the trap actually gets there, or the inform actually gets there. When it's acknowledged, they call it a trap. So trap or inform. Inform is a trap that gets acknowledged. It's that simple. There's not much else to it. If no ACK, then the inform is resent. So typically in a production system, if you're going to be utilizing traps, you'd probably send it as an inform, so it gets acknowledged. There's a little, like I said, it's a little more assurance that it's going to get there. So the information in the inform is similar. It's exactly like the information in the trap. And you can do this with net SNMP. Now in our lab 3, we're going to use the simple trap, not the inform. We're just going to use that for demonstration. But as I mentioned, in a production system, if you want to make use of those traps, you'll probably use the inform kind of a version of it. So the agent's also configured with these community names, community strings as they call it. There's read-only, read-write, and a separate one for traps. And once again, many vendors use those the string public and private as default community strings. We'd always want to change those. So it's a good practice to always change the default community strings. And some programs look for devices like printers with the read-only community string public. You don't really want to have stuff on your network with that community string. Maybe printers in a small environment like the classroom here. So here's the summary of our terms from our topic on SNMP. There's the versions, version 1, version 2C, and then version 3, which we'll look at later. We have our agent, which is on the switch or router. We have the NMS, which is your network management station. We have the community string that's used in that version 2C, that's clear text. We have the concept of polling, where the NMS regularly sends requests to the agent. And then that concept of traps and informs, where something happens on the switch and the agent on the switch of its own, it's programmed all by itself. It just sends the information to the NMS, which is listening. And we have the concept of MIBs and OIDs, and this is the information that's exchanged using that. So there's the summary of terms. That's the end of part 2 here. So you're probably ready for lab 3. So we'll go ahead and do lab 3, and that's it for the traps presentation.